Hello everyone, this is Vishwas and welcome to my YouTube video. As a part of this video, we will be talking on one of the most important and trending front-end architectural pattern, that is micro front-end. Initially, we will be talking on some theory part of the micro front-end, like to understand what is micro front-end, why we need it, when to use it, what is the pros and cons of it. And to understand this functionality in detail, we also little bit talk about the old way of implementing the application, that is monolithic architecture. And once all those things are done and we are good with the detailed understanding about micro frontend, then we will talk about implementation part of it. So for implementation, we will take 3 different React application and try to implement all the 3 application independently, and then finally we will compose those application into parent application. So let's begin. So first thing, we need to understand the old way of creating the applications, right? What are the drawback we have in monolith architecture, and how exactly micro frontend will resolve those drawbacks. So first thing, like in monolith architecture, we have multiple components are combined into one large applications. That means like we have front end, back end, database. So in monolith architecture, everything is combined as a part of single repository. And even we take the example of large applications, that is some e-commerce applications, right? In front end, we have different modules. Like we have login and log out, that is authentication of the user. Once user is logged in, we have product listing, product details. Then we will add those product into the cards. Then we have payment. And once payment is done, we need to track that order back and forth, right? For that, we also need the online help desk support. So initially, all those things are present in the single repository in monolith architecture. So here, all the modules are reside in single repository, and we have single CI/CD pipeline to deploy all the changes. As everything is present in the single repository, we have single CI/CD pipeline to deploy all the changes on different environments, right? And due to single repository, we will be facing, or we are facing multiple issues with monolith architecture. That is like we're facing difficulties when multiple teams are working on different modules, right? As application is large, we have multiple teams to handle different modules in single repository, right? So due to single repository, we can face the issues of conflicts, right? Multiple teams are working on different modules, but when they are creating the pull request, merging their changes into develop branch, we can face the conflicts, right? Then we also face the issue with the deployment. Like whenever we are making changes in just single module, right? Still we need to deploy entire applications to the production. Then then for that, like we need to manage the branching, we do the regression, then we need to perform end-to-end testing. Even we are making changes in single module, we never know that like which part of the application will impact. So that we need proper regression, end-to-end testing when we're deploying your changes to production. And next thing, like we also have constraint using different technology stack. As everything is present in single repository, we we need to go with single technology stack, uh, even like we have multiple modules. And to overcome this problem, in the backend, we started using microservices. Uh, Microservices are basically the independent um services that are divided by using different modules, and each service having their separate repository. they are deployed separately, and those can be used independently in your front-end applications, right? We just need to make the necessary API calls based on service, and those services are work in the isolation. So in the backend, like we handle that problem with the help of microservices, and in the front end, we need something similar, right? And that's why micro front end now comes in picture. So let's understand what is micro front end now. So when we talk about the micro front ends are implemented on the base of microservices from backend. Like in the backend, like we are dividing the services into independent modules. Similarly, in the front end, we can use the similar way with the help of micro front ends. So micro frontends is a UI architectural pattern where large application with numerous functions are break down into smaller autonomous modules or functions. So as I mentioned, with the help of micro frontend, right? If you have large application with the different modules, then we can divide those modules into separate applications. Like each application will work as an independent module, and then we are finally combining all those applications, or we are just composing those applications finally on production. So here each module can be developed independently by a separate team. They can have their separate repository, separate CI/CD pipeline for managing the code base and deployment. Now, here we are dividing our large application into different modules. So each application can be handled by different team, or each module can be handled by different team. They have their own CI/CD pipelines and separate code base for managing that application. Due to dividation into different modules, team can release module version independently, offer frequent incremental updates without affecting the other modules or functionality. So as we divided application or module based on the based into different repos, right? We can have um, module version independently. That means like if we need changes in one of the module, the team can immediately work on those changes and they can deploy those changes on production, right? So here we are reducing the dependency, and so that like development deployment will be much easier. And finally, each team can decide their own technology stack. As we are separating the repository and modules, each team can have their uh, own technology stack for developing the changes. Now, to understand this change with the help of diagram, let's see, like consider we have three different micro front ends, right? Micro front ends are nothing but the three different modules. Uh, each module is having their own separate uh, repository. Then they can have their separate CI/CD pipeline. Uh, this is for first application. Maybe this application is responsible for authentication. Then second application may be responsible for like product listing or getting the product details and payment. So for this application, we also have their separate code base, separate CI/CD pipeline, separate team is working on that. And then we have third application uh, or third module. Maybe it is related to online support and user queries, right? So this application is also having their separate repository, their separate CI/CD pipeline, and at the end, all the three applications are deployed to production independently. That means the application EA will be deployed on separate domain, same for application 2 and same for application 3. And finally, all these three modules or small applications composed into one single production application. That means the first part of the application is coming from the micro frontend A. Then second part of the application is coming from the micro frontend B, and the third part of the application is coming from the micro frontend 3 or micro frontend C. When we are combining those application into production, we just need to understand the two things. The micro frontend or module, right? Each module we need to call it as remotes in the term of micro frontend, and the parent applications is called as host application. Now, further to understand the detail, like most of the things are same as a previous diagram, but if you look at here, all the three different micro frontends can use a different technology. That means the micro frontend A or module A can go with Vue.js. Second module can go with AngularJS, and third module can be go with React. Then they have their separate CI/CD pipeline, separate repository, and those applications are deployed to production independently. And finally, we are composing those application into the parent application. And then your application will be working on production as a composed application with different modules. Now we will be talking about the advantages, like what are the advantages micro frontend will provide over the monolith architecture, right? So first thing, we will break down the larger application into smaller modules. So we have separate repository for each application. They have their separate CI/CD pipeline, so that here we are reducing the dependencies, right? So this is first point. Then second point is the increase autonomy of independent team. As the separate team is working on each module, they have their expertise in that module, and the module can be independently managed by that particular team. Then third point is faster development, faster deployment, as we have separate module for uh, each workflow. Then the team will decide their deployment, their development, um, and things are not dependent on other team, right? So that we can have the faster development, faster deployment. Then we have reliability. Then we have scalability. If you want to scale any of the module, then that can be scaled easily. And last point is diverse technology stack, right? As each team is responsible for particular module and we have separate repositories, team will decide their technology stack, like in which technology they are comfort on. The based on module, the team can go with different technology stack. So these are the some advantages of micro frontend, but there could be some issues, right? We need to uh, consider those issues as well while implementing the micro frontend. The first thing, like we need more collaboration among the teams. As we divided our uh, large application into smaller independent modules, we need to make sure that the UI or UX for all the applications are same, so that when we are finally um, combining those applications on the production, it should looks as a single application. Then there could be a chances that multiple application can share data between each other, right? Multiple modules can share the data to make it as a single application on production. So we should be more uh, active when we are deciding the contract, right? Or whenever any change, any team is doing the changes, need to make sure that teams are uh, well informed. Other teams are well informed about the UI data sharing, so that necessary team can work on the required changes. And second point is about sharing the functionalities, right? If two modules are sharing some common functionality, as we are dividing code into different repositories, sharing that functionality or libraries will be difficult. So these are some common issues with micro frontend. And while implementing that, we should take care of those. And when your application is growing, the complexity of using micro frontend increases. Like we have different modules, and managing those different modules on the production will be difficult. So considering that, we should implement your micro frontend. Now next point is when we should use micro frontend, right? Um, the simple thing, like when we have very large application with multiple functionalities, in that case we can go with micro frontend. Or for single application we want to go with multiple technologies. Maybe one module needs to be developed in AngularJS, other module needs to be developed in React.js. In that case, we can go with micro frontend. Or third thing, we can use micro frontend when we are migrating your applications, right? Consider we are developed your application in some old technology and we are migrating them into latest technology stack, right? And we want to go module by module, then we can use the micro frontend, right? So some of the module can be using old technology, and some of the modules can be developed with the new technology. And finally, on the production, we have uh, combined things, right? Few modules will be working with old technology, and some modules will be working with new technology. And as per bandwidth, we will migrate everything into the new technology stack. So this is all about the initial theory part. Now we will be working on actual implementation, right? So for implementation, uh, we will be implementing micro frontend with the help of Webpack 5, and in that we will be using module federation plugin. So with the help of a Webpack 5 module federation plugin, we can achieve the micro frontend. And to understand the implementation, we should have some basic understanding around the Webpack, like what is Webpack, why we need it, then what is the different terminologies in Webpack, like what is entry, what is output, how exactly we are loading the different loaders, what are the different plugins we are using, then how we are optimizing your bundle, then how exactly we are using the dev server. So if you have some understanding around that, understanding the module federation plugin is very easy. Then second point, we are developing all the three application in React.js. So having the basic idea about the React will be a plus point here. And third thing is that all the three applications are developed independently, right? And when we are using one application into parent application, uh, like when we are importing that application, that should be loaded asynchronously, right? So we don't know how much time that module will take. So to implement asynchronous functionality in React, we will be using lazy loading. So if you some idea around that, that is again plus point. But implementation can be generic, right? We don't need to be expert in React. You can understand the things, and that can be implemented in any of the framework, whether it is Angular or Vue.js with some minor modifications. Now let's talk about three different apps that we have already created with basic implementation. The first app, which is running on port number 3001, and this app is basically responsible for managing all the generic functional components, right? So this component I created considering the card details. If any of the application want to show the card data, with similar functionality, they can use this card component, where initially we have image and then some detail about that particular card. And second application or second component I created here, like here we have just image and then title of that product. So again, if any of the application want to use this, then they can use this component in their application. So consider my first application is related to just creating the common components, and one single team is responsible for creating this. Then second application I created like just to show, consider it as an independent application, and that is working on port number 3002. And here we are managing the product list, right? So I have the product that we want to order in future. So I will be creating just to-do list and show that here, right? So we can add the new product. Then you can delete that product, right? So this is just a small demo application, and this is the independent module. And then third application I have, you can consider this as a parent front-end application, micro front-end application basically. So initial two application, we can use these two application in our parent. So in parent application, this is working on separate port number or separate domain. So it is working on port number 3000. This application is having some header, some footer, and then we are making the API call and fetching some details here. And our aim is to use these two particular components from my child application into my parent application, and show that details here in first part. And in second part, we will be showing the to-do list. That is the my second application. So finally, in my parent application, we will be combining these two micro front ends. Now, let's talk about the code structure or initial code structure for all the three application. For that, we will go to VS Code, and if you see here, I have three different application. Each is present in different folder. So first one is components. That application is responsible for managing the common components, and that application is running on port number 3001. Then second application is MF app. This acts as a parent application, and that is running on port number 3000. This one. And then we have third application, that is to-do list, and that application is running on port number 3002. All the three applications are almost have similar folder structure. If you open the application one, at the root level, we have package.json file. In the package.json file, we have all the initial configuration. Then we have required dependencies like React and React DOM. And then we have all the required dev dependencies. We have Babel configuration, then we have Webpack, then we have required loader server. Also, we created two different script. One is build script to build our bundle, right? Then we have Webpack config file. This file is also simple. We are doing all the required configuration. That is required entry file, output file, then dev server. This application is running on port number 3001. Then required plugins and modules we have. So we are using JSX, we are using CSS and images. So to handle those kind of conversion into JSX, we are using loaders. Similar configuration file like Webpack configuration file and package.json is also available for my parent application, and then also for to-do application. Then if you talk about my component application, we'll go to SRC folder, and in index.js, I'm importing the app component. And this app component is again importing two different components. One is card details component and one is card short component. And in my app component, we are just making the necessary data. For now, this is hard coded at application level. But when we are importing that application in parent, we will be implementing that with generic logic or generic data. Then when we are returning our component, we are just calling that card component and short card component. And when we go to this component folder, and if we look at card details, this is same component. Very simple, just taking the required props and returning the data. And this is the component card detail. Then we have card short component. For that, we just have image and the title, right? So you will see that here, the card component with the image and required title. So this is my first application. Then second application is to-do list, where we discuss about the package.json file, similar kind of a package.json with all the required dependencies, dev dependencies and script. Then we have webpack config file, where my application is running on port number 3002. And if you open src folder and look at index.js, we are just importing the to-do app component. And when we go to to-do app component, this component is responsible for showing all the data here. So we have product list, input, then we have add button, and when we add the detail, we will see the product list and delete button for that, right? So you will see all those details here. So add a to-do, delete to-do, and then we have to-do from and to-do list. So this is my second application. And then we will talk about the parent application, right? Similar implementation for package.json and my webpack config. My application is running on port number 3000. Then we will go to the src folder where we have index.js file. And in index.js, we are importing the app component. In my app component, we are just making the two API call. The first API call to show this is basically the dummy API call to fetch the product recipes. And we will just fetching the 5 products with fields ID, name, image, cuisines, and ratings. So this API is useful for detail card. And then second API is used to fetch just 5 product with ID and image and its name, right? And this data we will be using for component, basically short component. And once that is done, we will go below. We just created 2 static component. One is my header component, where we are showing the title of your application, and in footer we are just showing some details. And in app component, we are just importing that. Here is header component, here is footer component, and in between we are just iterating the data we are getting from APIs. And for now, we are just showing name of this product. And here we have container to show the to-do list here. So this is my data which is coming from API, and here we have to-do app container. And when we actually combining this application or merging our child application into parent, our aim is to in first hub show this API data with this particular component. And in second hub of the parent page, we will be showing this to-do list here. That's all about the code. Now let's start with the actual implementation with the help of module federation plugin. To start implementation, let first take only 2 application. First application is a remote, or this is module of the components application, and then we will have parent application. And what we will do, we'll try to integrate or use 2 components The first component is my card detail, and second one is card short. And we'll try to import this component into my parent application. So to achieve micro frontend, we need main changes in Webpack config file, and that changes will be applicable for my child application as well as my parent application. So we will get some changes in Webpack config of my component module, and then we have some changes in Webpack config of my parent application, that is host application, right? So let's start with the first component or child application. And to start with actual implementation, first we need to import the module federation plugin from Webpack. To implement it or import it, we will import it as a name export. And for that, we need to require the Webpack, or basically import the Webpack. And from Webpack, we will require container. Once this is done, then we will import module federation plugin as a named import here. Once this is done, we will go to plugin section, and here we will create the new instance of module federation plugin, and then we will work on the actual configuration. So when we are making changes in a remote application, that is for particular module, we will require three uh, different fields. The first field is name. For now, I will give name of this as a common components, and this name will be required in my parent application to basically import the application from this child. So we'll discuss more on that. So this is name property. Second, we will require a file name, and for file name we need to go with some standard pattern, and we call that file name as a remote entry.js. This file will contain the component details that we want to expose to outside world or to parent application. And third property is used to expose the application. So when we are um, exporting some of the components from React, generally we use the export property, but to expose the component from module federation plugin, we need to use the expose property. And once that is done, here we will be mentioning our component that we want to export. The first one is name of the component, and second one is path of that component. So name of my component is card detail. For now, I will just copy paste this name, um, or I will directly use that name. We need to use something like this and card details. Card details, and then for the path, I will just right click on this and copy the relative path. Try to give exact path. If any of the spelling mistake happen, it will be very difficult or tricky to debug the micro frontend configuration. So we added this particular configuration now. This is name of my component that I want to export, and it's path of that component. And believe me, only this particular setting will be required in my child application. Now I save the file, and as we made changes in my child application, in Webpack config file, we need to restart my server to reflect those changes. So let me open the terminal again, and we'll go to the component, and currently my dev server is running. So we'll just stop it and run it again. So this dev server is started and it is working as expected. And now if I go here and try to access remote entry.js file, right? We will see this file is created by the Webpack. And if I try to search this particular component in that file, you will see that component in export of Webpack, right? That means this component is exported by the Webpack for the outside world with that remote.js file. Now we are good with our child application. Now let's move to the parent application and see what configuration we will require. We'll close this one, and now I will open the Webpack config of my parent application. Here we also require similar changes. We need to import the module federation plugin from Webpack. For that, we will first import the Webpack, and then from container, we'll basically name the export module federation plugin. Once this is done, we will go to plugin section. Again, we will create the instance of module federation plugin here. And here also, we will require three properties. First property is name. So I will give name as a micro front-end host application. Then second property is file name. And here again, we will follow the same standard, and file name will be same again. Remote entry.js. And now we have third property. Third property, we are importing component here from my module component, right? So basically component is basically the module, and that module is exported some components. So this component is exported from the module, and now I want to import that component in my parent application. So for importing any of the component, we will use remotes properties. And once that is done, again, we have similar configuration. We need to give the name of the component here. And the second one is path from where we are reading that component. So to understand the detail, I will give now name in detail. So this is my detail component, right? Detail card. I will give some meaningful name to understand, like we will be using this in our host component, right? So name I have given detail card in host. And now I need to give the path from where I want to import that component. For that, I will go to my again remote entry file that is in application is running on port number 3001, and I will copy this. Once this is copied, I will add it here, and I also need to provide my application name from I need to use this remote.js entry file, right? For that, I will go to my child application again, and now this name property is used. So I will copy this and use it here. And then we need to give the @ symbol. So this is my name of my child component from where I'm importing the data, then @ sign, and then path of my remote entry file of the child application. And once this is done, we are done with basically importing the component. This is done now. Let me also restart my parent server, as we made changes in Webpack config file. So I will stop my server and restart it again. Now, if you look at here, my application is working as expected, right? And now our aim is to replace this particular content. We already making the API call, and now we need to use my child application in my parent. So to do that, we will go to my app.js file of my parent application, right? Here, we'll go to the parent, we'll go to src folder and look at into app.js. So in app.js, we are making the necessary API call. And if you look at here we have detailed container, right? And now here we want to use my component, that is card details component from my child. And to import that component is basically present in different application. It is available on different domain. So we can't import it directly. To import that component, we need to use the async manner. And to achieve asynchronous loading in React.js, we need to use the lazy loading concept from React, right? So to import that component lazily, I will use lazy loading. For that, we just need to use the import the lazy from React, and then I will give name to my component, right? Suppose card details. This is my component. Then we will use lazy method of React. It will taking the callback function, and then we will use import here, right? And in import, we need to give the exact uh, name of the component that we want to import. So to import this component, I will go to my parent webpack config and use this particular name. Just to understand the syntax, first we need to give the name of the remote. So here I have remote and I given the component name as a detail card in my host application. So we'll give that name, and now we need to give the exact name of the component from my child webpack config. So we'll go to my child component and we'll see the name from exposes property. So in exposes, I use the name as a card details. And if I go here, I will add that name. We'll save here. This component we imported from child application. And if you go to child application and see at the card components, the card component is expecting data props, right? Data props, and in that data props, we will require these fields: image, name, cuisine, and rating. And if I go to my app.js file of my parent application, here we are making the API call and we are fetching all those required fields. So what we can do, we will just use this component, go to the detail section. Here we are showing that component, and instead of returning the li, we will use our component here, card details. Then here also I will use the card detail, and as a data props, we will pass our item. Yeah, those changes are done, but as you know, we are loading this component lazily, and until these components gets loaded, we need to show some fallback logic on UI, right? Maybe some shimmer UI or a loading spinner to indicate that the components is loaded asynchronously. And for that, we need to use the suspense from React, right? Those who are having good understanding on lazy loading, they definitely know when we are lazily loading the component, we need to wrap that component in suspense. So here I will go here and will now wrap my component around suspense. So this is my suspense, and we'll end it here. And suspense is expecting one mandatory uh, uh, props, and that props is fallback. So fallback, we can give any shimmer UI, or as I mentioned, we can just give the loading text. JS6 is also allowed here, or even we can give the null text if needed. Just we will give the null here. And once that is done, we will save the changes. And believe me, we are good. Now we will go to parent application and we will see like these things are getting loaded from my uh, child applications, right? If you look at this card component, those cards are getting loaded here. To verify this, we will go to, we'll basically inspect it. And now if you go to sources, you will see like some details or some file gets loaded from localhost 3000. And if you come down, you will see some data is also get loaded from my application localhost 3001. That is my child application. You will see the remote entry.js file. Then we have some other files, right? Uh, Bundle file and everything. So that means something is gets loaded from my child application. And now just to confirm, if you go to my child application again, right? In my card component, so card details component, right? You will see that the price is hard coded here, right? That it's 250. And we'll try to change this price. If you look at here in my old application as well, that means in my child application, you will see this hard coded price. And if you look at this dynamic data, right? You will see the hard coded price as a 150 for all those, right? And now we'll try to make changes in my child component. So instead of 150, I will give price as a 200. Let me see if my child application is updating. Yeah, it is updating with latest value, right? That is 200. And now if I go to parent application and refresh my page, you will see all these components are updated with the latest value from my child. See here, it is updated with value 200. Now, just to understand things in more detail, what we can do, we will try to also import this component uh, from my child application into parent. So we'll try to show that component here. So we will get more understanding around this. And now you will see that most of the things are repetitive. We have repetitive work. So for that, first I will go in my child application, will go to the webpack config file. Now most of the things are ready. We just need to expose one more component here, right? So for that, I will use new name, that is card short. And for that, I need to give the appropriate path of my child component. So this is my card short component. I will copy the relative path and use it here. We'll just go to src folder. From here, we'll use this. And now we'll do the path changes. Now this is done. As we are making the changes in webpack config, we need to restart our dev server. You will see my remote entry file gets updated with the latest export component, right? So let's see here. Initially, it's exporting the card detail. Now it is also exporting the card short.js. That's all changes we will require in child application. Now we will go to parent application and go to webpack config file. Most of the changes are already done. We just need to go to the remote section and we need to import that component again. Things are pretty much same now. Here we'll copy paste this, and instead of detail card, we will use short card name, right? And we will be importing this data from my child component. So this is my name of my child application and then path of remote.js entry file, right? So this will be the same. Once that is done, I will save this. And as we made changes in my webpack config, I will restart my server again. So this is just stopping the server and let's start that server again. Until that server gets started, we'll close this application. And now once the server gets open, you will see the application is opening again, right? Now we will go to the app.js file of parent, and now we will make the necessary changes, right? We need to import the component lazily again. So we'll give the short name to it, card short. Again, we need to use the lazy loading to lazily load that component. And then we need to look for particular path, right? So path is simple. The first component name will be coming from my parent application webpack config file from the remote setting. So name will be short card in host, that I will add here. And second component name will be coming from my child component, or child component webpack config. It is from exposes and this short card. We'll just add it here. And once that is done, we will be required similar changes here as well, right? So instead of doing that, I will just copy paste this and use it here now. Suspense is there. Instead of card detail, I need to use card short. And once that is done, we will go to card short component from my child application and see what things it required, right? It is expecting data props, and in data props, it will be expecting image and name. And if you go here, you will see this from this API. We are importing the, or basically making the API call and getting the 5 items, and we are importing the fields name and image. And if you come down in the card short, we are passing those details, right? We'll give this name is name capital, just to have the proper coding standard. And here we'll use that capital name. And once we save this and go to my application again, you will see that component is also gets added now. So we implemented our first micro front end from our child application or remote application. We just imported two components into my parent, and we are using that with real-time data. Hope that is clear. Now we are completed with our first part. That means we successfully implemented our first micro front end, where we are importing couple of components from our uh, remote application or component module into my uh, host application, right? That is my parent application. So first part is completed. In second part, we are planning to load one more application on my parent, right? So for that, we have created the to-do list application, and now we will just import this entire module or independent application into my parent. So we'll load that application here. Okay, now let's start implementation of the second child applications, right? For that, I will go to my application, will go to webpack config file, and now we need to follow the similar implementation. First, we will import named export of the module federation plugin from webpack. We just need to use the required here. Then we need to use the we need to import the webpack, and from webpack we need to use the container here. Once that is done, we need to import module federation plugin here. So we did that. Now we will go to plugin section. We will use new keyword here, and then we will start the configuration. Now, first configuration or first property is name property. For that, I will give name as a to-do app. Then second property is file name, and we need to follow the standard. Here we have remote entry, right? Remote entry.js will be file name, And now third property is exposes. Uh, I want to expose uh, this particular component, right? To do app component uh, to my parent application. So we'll just copy the relative path here, and then we'll go to Webpack config file, and here I will give name of my component, and then I need to provide the relative path. So for that, I will use the src and then my to do app here, right? To do app here, and for now, I will give the component name same as to do app. Once that is done, we will save these changes, and now we will uh, start our server again. It is started on this particular port again, and now we are done with our child changes, right? Uh, will now go to my parent application, and here we just need to import that component, right? So we already done with the initial settings. Here we need to add the third component that we want to import. So to do app host, I will give this particular name, and now I want to read it from here, right? So I need to find the name of the component that we will be find, or name of the application that will be find here, that particular application name, and then I need to use the @sign, and we need to use the path of remote.js entry file, right? So if you go here and see for the remote.js entry, we will find it. And if you want to find a particular component that we are exporting, you will also see that here. So not here, but here, right? So in the export, we will see the to-do app component. So we'll just use this file path, and I will use it here. Now we are done with Webpack changes. Let me also restart the server so that latest changes will get reflected. Uh, npm start, right? We'll see my application is loading, right? We'll just go back here, and we'll now see uh, the applications, right? And now we will do the necessary changes again. In my parent application, I want to now go to uh, src folder, and in app.js will basically import my uh, component, right? So again, we need to use the lazy loading here. We will use to do app. Then we will use the that component lazily, and then we will use the import here. And things are simple. We just need to use this name from your parent from remote host. So we'll go to the remote properties, and we will find that name here. Um, I'm using that name, and then second name, we need to use the component name from your child application that is present in exposes, this one. I will do that, and now we'll try to just load that component, right? Again, we will use suspense here. Suspense for fallback. Uh, uh, for now, I will give null here, and then we'll go close my suspense, right? And in here, we will use that to do app. All these changes are done. Now we'll go to the parent application and try to see what's going wrong. If you look at here, we are getting some error, but to understand the error in detail, We'll close this and we'll open the developer tool. And if you go here and try to find error in console, you will see detail error here. And here we need to focus on this particular error. You might have more than one copy of React in same app. The error is simple. We are using our child application or the child component in parent, and uh, like multiple copies of React is getting added on the page. That means one copy from your child application, one copy from your parent application. And when we are implementing the single page application, the single page application is expecting that only one copy of such framework or library should get loaded on the page. Now to resolve this issue, things are simple. We just need to go to your Webpack config file, both child and parent, and need to add one more property. In my child application, I will go here and add one more property, that is shared. That means in this shared property, I will add the dependencies that is shared across my child and parent. And those dependencies will be React, and then second one is React DOM, right? React DOM. So I did the necessary changes in my child application. So let's start the uh, server again. Similar changes we will do in parent application, and uh, see if that issue gets resolved. So this is shared, and we'll share a couple of uh, libraries. The first one is React, and second one is React DOM. We'll save this, and we'll also restart my parent now. See if my application is running. But now if you look at here, my parent application is not working, right? Let's see if parent is working, or even my child application stop working, right? Now to see that detail, so this is my application, this is my child application, and this is my parent application. And now both the applications are not working. To see this, we will again go to console and try to find out the error. And error is saying that shared module is not available for eager consumption. This is again simple error. We need to just understand the error. And error is saying that the whatever the property we are using here, this property, right, shared property, we are not able to find these two dependencies. The first one is React, and second one is React DOM, and that is due to uh, uh, our index.js file, right? Our application is basically loading from index.js, and uh, once the index.js file start loading, it's not able to find the React and React DOM dependencies. And to resolve this issue, we just need to delay the execution of this particular file, right? And the fix is very simple. Now we will go to our child application and create one more file in SRC. The file name, we can give any file name, but I will give name as a bootstrap. Like we are just changing the way to bootstrap our application, right? So bootstrap.js, and I will copy the entire content of my index.js and copy paste it in bootstrap.js. And in index.js, I will just import this file, bootstrap. And I think that's all. Only that's changes we will be required in my uh, child application. Let's see if it's the resolve issue. Yeah. Now my child application is start working, and similar changes we will be required in parent application, right? So let's go to parent application, go to src folder and create new file, that is bootstrap.js. Copy the content of your index.js file and paste it in bootstrap, and in index.js just import your bootstrap file, right? So with the help of this, what we are doing, we are just changing the way to bootstrap our application, and we are basically delaying the execution of our webpack config file, so that whatever shared entries we have, right, React and React DOM, that will be available. Now I save this file, and if you go to my application, the application is start working again, right? And if you go to bottom, uh, my second remote application also gets added on parent now, right? So this is my uh, second remote application, and we successfully also integrated that in parent application. And to see if the functionality is working, we'll just add some detail, and you see it is working as fine. Pizza. So if I delete it, it is working fine. So now we also integrated second micro front end in my parent application. And I think that's it. We are good with this. I just want to inform one more thing. I forgot to inform that earlier. But whenever we are exposing any component to outside world, right, that component should be default export. So if I go to to-do app and look at my to-do app, right? If I go here and look for my to-do app.js, you will see that as a default export, right? Our component should be default export, so that that should be available for outside world. Named export are not allowed here. I think that's all about this particular demo. We successfully added a couple of micro front end in our parent application. Now, as a part of last step, let's just summarize the things we learned today. First, like we went with the old monolithic architecture and its drawbacks. Then we talk about the micro front ends, like what is micro front ends, why we need it, how exactly we can implement it, how it overcome the drawback of old monolith architecture, right? Once that done, we talk about the actual implementation of the micro front ends with the three different application with the Webpack 5 module federation plugin, where we created two remotes application and one host application, and through our remotes application we exported few components and use that component in our host application. uh, for the implementation, we will require changes on different places. First change will be in Webpack config of your uh, remote applications, where we are exposing component to outside world. Then we will require change in your parent or host application, where we will import the component that is exposed by remote application. And third, like we will use or import that component asynchronously or lazily, and then we basically just call that component inside our suspense with some fallback logic, right? Yeah, that's all about summary. After that, now we just talk about the uh, upcoming part, like what we'll try to cover in next. For that, like as a part of upcoming video, right? We will try to implement micro front end with different technology. Like for now, we just went with the three different React application, but we'll try to add two more application, one with Vanilla JS and one with some other framework, maybe Angular or Vue.js. Then we will talk about the routing, where we will manage the routing in your parent application, and we'll see how exactly that routing works into different child applications. Then we will also talk about the communications. Till now, like we just see how exactly we are uh, calling the uh, component from your parent, but we will also see like how exactly our child application send the data back to parent. We'll see on that. Also, we will see on the state management library, where we will go with Redux or Redux toolkit and try to see how exactly micro frontend will work or changes needed considering the state management. And finally, we will try to deploy those application independently on the server, and we'll see how exactly live micro frontend works. I think that's it from my side. For today's demo, I deployed that code to GitHub, and we'll share the link in description so you can go through it and try to implement micro frontend from your own on your system. And we'll see you in next video. Till now, thank you for watching this video, and happy coding. Thank you. Bye.